Welcome to video 4 in linear relationships. And in this video, we are going to, as you can see from the learning goals here, we are going to learn how to find the gradient between 2 points, whether or not you're given a graph. So maybe they'll give you the graph and show you where the 2 points are like this, or maybe they will just tell you the 2 points like this. And we're going to learn how to find the gradient in both of those situations. And number 2, understand how to substitute a point into a line. We're going to get to that because you won't know what that means yet necessarily. At the end, just to see if you have learned that, just test yourself. Try and find the equation of a line going through 2 points. Because that's the overall aim for what we're doing. All right, so we're just going to do 2 examples, and through those examples, hopefully you will see how to find the equation of a line if you know 2 points. So, first of all, we're going to find the gradient between 2 points. Just in case you don't know why we would like to find the gradient, let me remind you that we learned last time the gradient intercept form of a straight line. Now, this is going to be very useful in the next 10 or so minutes, because if we can find out what m is, and if we can find out what c is, we will have the full equation of the line. So let's say if m was 2 and c was 3, we would have y equals 2x plus 3, and that is a complete equation of a line because it has y and x but doesn't have any other variables like m or c. Alright, so the aim is to get to there. But we start here. We want to find m or we want to find c. So if we can find m, which is the gradient, we'll be one step closer, and then we'll only have to find c. So let's find m. So let's look at this line over here, and we will find m, which is the gradient. Now keep in mind that m, the gradient, we measure the gradient by finding the rise and dividing that by the run. So if we have 2 points here, we have to see how far am I going up or down, and how far am I going across to get from one point to the other. So let's do the rise first. It's actually a little bit trickier in this case because let's say we go from here to here. Rising is usually going up, isn't it? But it looks like we have to go down here. Now, how far are we going down? We can count. We can just look at this graph and work it out. So, how far are we going down? We're going down 1, 2, 3, 4, 5, 6. That means the rise is going to be -6, because if we were going up, the rise will be positive, but we're going down, so it has to be negative. So, I've lost my pen all of a sudden. The rise is -6, and the run, well, we're going from here to here. That's how far we're going across. How far is that? That's 2. So -6 divided by 2, which equals -3. All right. Now, what this means is we actually can write a new equation. We're one step closer. We don't have to write y equals mx plus c. We can replace this m with -3. So let's do that. Let's write this new equation. Oops. We're replacing the m with -3. Okay, now, the second step I think is a little bit trickier, but hopefully you will understand what's happening. It says substitute one of the points into your new equation to find c. Now, why is that going to work? Well, I want you to look at this equation and notice that there are 1, 2, 3 pronumerals. we don't want this c to be here. We want this to be a number. But we can only work that out if we don't know what if y and x are numbers as well. See, if I substitute a point in here, these 2 points, if I substitute the coordinates of one of these points into here, that point, those 2 coordinates will mean we can find c. Because there will be a number c that will make this equation work. So what we're going to do is we'll choose one of these points. Let's choose this point. Now, what are the coordinates of this point? Well, the x coordinate, I go down here to find out that the x coordinate is 0. But you should remember that if it's an intercept, like it is, then as a y-intercept, the x-coordinate is always 0. And the y-coordinate is, the point's right on the y-axis, so the y-coordinate is 3. So we are going to substitute this point into the equation. Alright, so let's do that. So what do we write instead of y? Well, we look at this point and we find the y-coordinate. So that's 3. Equals -3 times, what do we write instead of x? Well, first of all, we need to draw the brackets. -3 times 0, that's the x-coordinate, plus c. And so let's simplify this a little bit. 3 equals, what's -3 times 0? That has to be 0 plus c. If I'm adding 0 to something, then if I'm adding 0 to c, then I've just really got c. Doesn't change it. So 3 equals c. Now I want you to notice something strange about this. That's actually the y-coordinate of this point, isn't it? And something that we could have worked out beforehand is that because this is the y, we just talked about this being the y-intercept. So really, if you understand what c is the y-intercept, you could have just said, oh, well, I don't even need to substitute this particular point. I could just write my new equation with 3 instead of c, and that would be exactly right. But I did this method just because you're not always lucky enough to know what the intercept is. Sometimes you have to substitute another point in there. Alright, so my final equation is y equals -3x plus 3. Because my gradient is -3 and my y-intercept is 3. And just to recap, we worked out the y-intercept. There's 2 ways of working out the y-intercept in this particular example. One of them is just looking at it and noticing that it goes through the y-axis at 3. The other one is substituting the point in. Now, even if I substituted the other point in, that would still work. I would still find out that c is 3. Okay, so that's the way to do it if they show you a diagram of the line and it's easy to work out. What if they only give you 2 points like this? So here's one point and here's the other point. So this one has 2 x coordinates. So this one has the x coordinate is -2 and the y coordinate is 5. This one, the x coordinate is 4 and the y coordinate is 9. Now, we do the same 2 steps, right? So first of all, we find the gradient between the 2 points. Second, we substitute one of the points in. So finding the gradient between the 2 points, there's an equation to find the gradient between these 2 points, and this is how the equation goes. It goes, the gradient m is, well, we'll just write rise over run, because it's always good to remember. It's y2 minus y1 over x2 minus x1. So you might look at that and say, what on earth is that? And there's two things we can do to make this a little bit easier. The first thing is to work out what exactly is y2 and y1 and x2 and x1. And to do that, you can write down the coordinates of the points, and you can say this is point 1, and this is point 2. So hopefully, it doesn't matter which point you choose as point 1 and point 2, by the way. Now hopefully this is starting to make a little bit more sense, because if you think, okay, what is y2? y2 must be the y coordinate of point 2. So that's y2. What's y1? The y coordinate of point 1. x2, the x coordinate of point 2. x1, the x coordinate of point 1. So now we can straight away put these into our equation. But before we do that, I want to help you understand why we got this equation in the first place, which is really, it's the same thing as what we did here. So y2, think about it, y2 minus y1. Let's say, before I said the rise was 6, right? Sorry, negative 6. But really, if we have to find the distance here, the way to do that is take one of these numbers as this one minus this one. Now this negative 3 is y2. Why is that? Because the coordinates of this are, the x coordinate is 2, the y coordinate is negative 3. And the coordinates of this one are 0, 3. So this one is y2, if this is point 2. y2 minus y1 is just negative 3 minus 3. What's that? It's negative 6. So if you want to find the distance between two numbers, you just subtract them. And that's exactly what we're doing here. So y2 minus y1, let's do it in this case. So y2 minus y1 is 9 minus 5. And x2 minus x1, so that helps us find the rise. To find the run, we do x2 minus x1, 4 minus negative 2. When I'm subtracting, 2 negatives make a positive, so that's the same as 4 plus 2. So 4 over 4 plus 2 is 6. Okay, and I can simplify this fraction a little bit by dividing both the top and the bottom by 2. If you don't know how to do that, write a comment perhaps, or there'll be some resources available somewhere on the internet for that. Probably in lots of places on the internet. For simplifying fractions. Alright, but that's our gradient. And it's okay for the gradient to actually stay as a fraction like that. That's fine. So our new equation has to be, we rewrite the general form y equals mx plus c, except instead of m, we have to write this. Y equals 2/3 x plus c. Alright, so let's substitute one of the points into the new equation to find c. So I'm going to choose the one without any negative numbers, because hopefully that will be a little bit easier. Alright, so let's substitute this point in. So instead of x, we're going to write 4, and instead of y, we're going to write 9. 9 equals 2/3, and we'll write some brackets, 4 plus c. Now this is going to be a little bit tricky, because we are going to have to work out how to times these two things, and then we're going to have to get rid of it so that we can have c on its own. So how do you times these two things? Again, with fractions, let me know in the comments if you want help multiplying fractions. But 2 over 3 times 4, remember, if I have a number, I can change it into a fraction by dividing by 1. Why would I want to do that? Because if I am multiplying two fractions, you just multiply the tops and the bottoms. So that's 8 divided by 3. And again, we'll leave it like that for now. So 9 equals 8 over 3 plus c. Now, let's say I had an equation 2 equals 3 plus c. I could subtract 3 from both sides to get rid of it, couldn't I? And now, just because we have a fraction here instead of a normal number, that doesn't change anything. We can still subtract this from both sides, because a fraction is still a type of number. So let's subtract it from both sides. 9 minus 8 over 3 equals 8 over 3 minus 8 over 3 plus c. And that will cancel these two out. So now we've got, and I'm running out of room for this. I'm going to rub this out. Now we've got 9 minus 8 over 3 equals c. Now, how do we make this into a fraction? When we're subtracting a fraction from a number, we need to make both of them into fractions. So we're very close to finding c. All we have to do is subtract these two. And again, if you want help subtracting fractions, let me know. So what you have to do is you have to convert this into a fraction, 9 over 1 minus 8 over 3. But that's not even good enough, because these two numbers, the denominators need to be the same. So how do we make the denominators the same? Well, if we have 9 over 1, I can multiply it. I need to multiply the bottom by 3 to make it into a 3. That means I need to multiply the top by 3 as well. So we're going to have 9 times 3, which is 27, divided by 3. 27 over 3 minus 8 over 3 equals c. And 27 minus 8 is 19, so 19 over 3 equals c. And so our final equation, now I can get rid of c, and instead of c I can write 19 over 3. And that's our final equation. Now, that was a little bit trickier in terms of the maths. If you didn't understand that, what I would recommend is going over it step by step. And if there's any step you still don't understand, let me know and we can sort it out. All right, so let's just recap. Did we meet the success criteria? Can we find the equation of a line going through 2 points? And now, if you know how to do these 2 steps, that means you know how to do it. So first of all, find the gradient between 2 points, whether that's using the graph, using the graph, or using this equation. And then you write a new equation. You take the general form and you replace m with your new gradient that you found, and then you use this new equation, substitute one of the points in, which is step number 2, to find c. Okay, thanks for listening, and I'll see you next time.